Hi, everybody. Welcome to Dreamforce. Welcome to San Francisco. My name is Roy Davis. I'm a senior product security engineer here at Salesforce. I'm going to talk about some common security mistakes that I see in AppExchange and when I'm talking with customers. So first things first, you guys have all seen this. I am not an investment counselor, and nothing I say should be taken as investment advice. I'm not going to really be making any forward-looking statements, so everything that's on here you guys can find online. So like I said, I'm a product security engineer here at Salesforce. I do lots of things. I wear lots of hats here. I manage the bug bounty program. I work with IoT and the software development lifecycle there, make sure everything is secure up front. I do a lot of volunteering as part of our 1-1-1 model. I am specifically interested in robotics teams, the First Tech Challenge through the high schools and things like that. I do some security research. I've got a couple ATMs in my garage at home that I'm tearing down and trying to understand how to exploit some of that. And I also play some foosball once in a while. This picture actually was taken in the Andes Mountains. I was there for a week in early May this year, and I brought Astro along with me, so pretty cool. So today we're going to talk about common security issues across the Salesforce platforms, things that make their way into AppExchange packages, and some common questions that I see when I'm doing office hours. If you guys are AppExchange partners, you may have talked to me on Tuesdays and Thursdays. So we kind of broke this down into injection issues and logic issues. Everything in green I'm going to cover today, but the time frame here, 20 minutes, didn't allow me to get to cross-site request forgery. But right over here, I can see the security station, and I'm going to be there after this talk, and I'd love to talk to you about that more. So first, we're going to take a look at injection vulnerabilities. So cross-site scripting is our first one. So what is this? Basically, this is where an attacker is able to inject code that runs in the victim's browser and causes data loss or access to data you're not supposed to have access to, or data injection, or cookie stealing, or things like that. There's three main types that we're going to look at: reflected, stored, and DOM-based. All right. The first one is reflected. So basically, the malicious payload is on a link, and you may receive like some sort of a phishing email, or maybe you get redirected to a site and there's a link there and it's maybe obfuscated so you don't really know what's happening, and you're clicking the link and you're trusting that the browser's looking out for your best interest, and it may or may not be. But in this instance here, we've got a pop-up where, so we've got example.com and some sort of query string parameter that is a script tag, and that is being embedded into the page when it loads. And commonly when we're diagnosing this vulnerability, we use alert document.cookie or document.domain, things like that. And what you can see here is looks like the cookies. So the cookies are popped up, and alert isn't really that dangerous, but if I can do this, I can do just about anything as that JavaScript does. All right. The stored attack scenario is where I'm inputting data as the attacker into a site that is then reflected or loaded back to another user. So a good example is like a blog site that a malicious user puts some code into, some JavaScript. The victim user comes along later and views that blog post, and here we go again. We've got our pop-up with alert with the cookies. All right. The example shows here that the attacker dumped this string into the email field of registration, and maybe an administrator or somebody came along later on and saw this. A DOM-based attack scenario is kind of separate from both of these because the server's not really involved. The document object model, that's what DOM stands for, on the browser side is being manipulated to load this malicious code in after the fact, after the server has sent the page off to the browser. So in this example, we've got a URL where we're we're trying to allow the user to pick a language, right? And here we say, default is French, and we've got some code in here that is pulling off of document.location.href. It's pulling the value and incorporating it into the DOM. And the attack scenario here at the bottom is basically just swapping out the word French and inserting some JavaScript. All right. So what could possibly go wrong? Why do we care about something like this? If the cookies on the browser, which are holding the session key, right? If that cookie does not have the secure and HTTP only flags set correctly, this type of attack payload will allow the attacker to exfiltrate your session cookie, which identifies you as logged into some system, right? We can exfiltrate that to some attacker's server, right? And this will show up in like the logs, or maybe I wrote some listener on port 80 that logs this kind of thing and sends me an SMS message, or maybe it spins up a session right there using that cookie value, all right? So we can see that we're concatenating document.cookie to the source URL of a new image that we're spinning up and adding to the DOM. And as soon as this gets loaded, off goes your cookie values and game over. All right. So how do we remediate this? A lot of people will say, well, let's filter the input. That's a good way, right? It's good. It's not everything, though. It's kind of weak. It's not foolproof. There are ways around it, especially if you're a good hacker. Okay? Dealing with the bug bounty program, I see some of the world's best hackers all the time, and they are very good at this. Really what you want to do, and what we encourage people to do, and what we do in our own platform here at Salesforce, is what's called output encoding, where we're swapping out the value, the character value, for its equivalent HTML entity code. So you can see some examples up here of less than and greater than, double quotes and single quotes, right? Being swapped out for their entity values. There's well over 200 entity values that can be used and swapped out. All right. Content security policy is another way to remediate this issue, and basically what this does is it tells the browser what's acceptable, where can I execute JavaScript, what kinds of tags are allowed. So in our basic policy definition here, all resources need to be hosted by the same domain, where the document originated from. There's no inlines or evals for scripts and style resources. This more hardened policy at the bottom allows images and scripts and AJAX and CSS from the original same domain only, but doesn't allow any other resources to be loaded, like objects, media, files, things like that. So this is another way to deal with it. All right. In our Apex controllers, there's actually some methods available to you as you're writing Apex code to do escaping of the output, okay? To make it safe so that you're not exposing your users to XSS. For HTML, you want to use the escape to HTML method off the TextUtil library. And if you have JavaScript in HTML, things like maybe an event handler inside a tag, you're going to want to use JavaScript in HTML. All right. In Visualforce, we've got a couple of different things going on here. Visualforce, I just spent the last hour actually trying to trick Visualforce into popping an alert box, and I was very frustrated because it wasn't working, and that's because we have a lot of things built into the platform to prevent this. The bottom one, though, however, if I take a current parameter from the page, something that the user is inputting, and I assign it to a variable in JavaScript, that's dangerous, and that is susceptible to cross-site scripting injection. Okay, the top here, where we have current page parameters inside a div tag, that's going to be automatically escaped for you, so you don't need to call any special properties there. In the Visualforce page itself, we have 4 different encoders available for you in the Visualforce page. So it depends on what you're trying to encode and what you're trying to output. If you have just JavaScript, you want to use JS encode. If you have JS in HTML, you can use that. And there's a couple examples here that show So the previous slide showed kind of an unsafe implementation, and this is the remediation for that on the previous slide. Okay, in Lightning, we have a couple of different examples up here. The first one where we're just basically inserting a value. That's going to be safe. That's going to be automatically encoded for you, as is the second value where we're setting the title of our div tag to some value from the database or some value from our backend controller. The third one here isn't going to compile because basically we're saying, this div tag is going to have some arbitrary property that's specified by something in the database, and that's just not going to work for you. Same thing with the fourth one here, where we're trying to embed into our title some value. But the fifth one here, where we're taking that same value and concatenating it, that is going to work for you. All right. The two at the bottom, we've got some JavaScript that you could inject here. This is very unsafe. You wouldn't want to do that because v.foo here could be some JavaScript. This is not protected. So if you need to do this, you're going to want to use the Apex controller side encoders that we showed a few slides back. The bottom one forces a relative URL. And it basically protects your page from clicking outside and loading some external resource or going somewhere else. All right. In Locker Service, so we got this giant JavaScript library called Locker Service, which encapsulates JavaScript and makes it safer. Okay. This started with API 40, but the newest one, 43, has a lot of fixes. We are constantly trying to improve it and improve the security of the Locker Service. So I highly encourage you to use the version 43. Basically, it prevents components in iframes and in frames from talking to other components, the rendered data, and having access to that rendered data. Okay. And it reduces the attack surface of JavaScript, like I said, by encapsulating it. I don't have a lot of time to go deeply into Locker Service, but I'd love to talk to you about it more over with the security station, and then we have a couple of links here for some trails that you can take. All right, so that's XSS. Let's go on to SOQL injection. So what is SOQL? It's basically Salesforce's implementation of SQL. We removed a lot of very dangerous keywords from SQL to make it, to reduce the attack surface. So there's things like inserts and updates and deletes and unions and joins, things that are commonly exploited to do SQL injection are not here in SOQL. There's no command execution available on the database side, no wildcard fields. You can't chain queries together using a semicolon like you can in like MS SQL and some others. So it's safer, but it still needs to be implemented correctly. So let's look at some issues with this. Let's consider a string concatenation sort of scenario like we have on the screen here. We've got some code that's on our Apex controller, and it's trying to do a SOQL query against the database. But it's doing string concatenation. We can see the where clause, right? We're taking some query value that we built up here, and we're concatenating it to this where clause that has user-based input, all right? So let's say that the user-based input is, and performance rating is less than 2, okay? And so what this is going to do is it's going to give me access to records that are beyond the CRUD-FLS and sharing rules that have been implemented by your system administrator. Okay, so this scenario is like you've got a list of a table of employees, and you've got this special column that says, hey, what's the performance rating of all of my employees, and you have access to that, but you don't have access to that column, right? Well, I can infer now, if I can do this SOQL injection, who the employees that maybe aren't performing so well, right? So it's elevating my access to data beyond what the user or the system administrator has set up. All right. So how do we mitigate this? Basically, what we want to do is treat variables as data only. Okay. So we are going to do use what are called bind variables. All right. And simply what you're going to do is you're going to prepend your variable with a full colon here. As you can see, we have title like colon Q title. Okay. That means that everything that's coming in now is going to be treated as data, and there's no string concatenation taking place where I can inject SOQL to get access to data that I don't have access to. If we're looking to use dynamic fields and object names in bind variables, we need to do some sanitizing and combine validation and permission checks. So this is kind of like a base class or a base function approach to doing that sanitization and putting all of those checks into one place so that you don't have to cut and paste, access checks all over your code, right? You just put all that stuff in one place. You have an object name that you send in, and then this one little function takes care of all those things for you. All right, so the next thing on the list is open redirects. So what is this? Basically, it's sending a user to another web page, typically after they've done some action on the platform, and they don't really know what's happening. They're not aware that they're being sent somewhere else. So we have an example here where we have some vulnerable site. The query string parameter start URL is normally set to this goodsite.com. Okay. Well, what if I change that and I send it right to one of you, and you're not really looking, or maybe I encode it, maybe I URL encode this, right? It's very similar to the entity swapping that we did in HTML encoding. So you can't really see what it says. It's just like a bunch of percent signs and stuff. And instead of going to the goodsite.com, you're going to go to evilhacker.com. So let's look at see what that looks like in 10 easy steps. First, we have Cody, we have Cody's bank, and we have the evil hacker site. All right. Now, I'm the evil hacker, and I want to get Cody's credentials to log into his bank, right? His bank doesn't have 2FA enabled, so I'm good to go there. I can start my attack with an email. I'm going to send him a phishing email, and it's going to say, hey, you better log into your bank because your balance is dropping quickly or something. Cody's like, oh no, I better go to my bank. So off Cody goes to somebank.com, but somebank.com is vulnerable to redirect injection. So here, the link that the evil hacker sent to Cody had a return URL of evil.com. All right? So here we go. The bank says, hey, here you go, Cody, log in. Okay, here's my credentials. Awesome. You are logged in. Redirect, theoretically, back to the start page so you can see all your dropping balance information. But instead, Cody's browser goes to evil.com, and Cody's not really paying attention. He's like, gosh, what happened? Well, you entered the wrong creds, right? And these are super simple to copy and make it look exactly like your bank. And if you're not paying attention, you're like, oh, gee, okay, well, I'm going to enter my creds again. And off they go, and like, okay, here they are again, I guess, whatever. Awesome, thanks, I'm saving those for later. I'm out of here. Back to the bank, okay? Now, because you already logged in, and you have a cookie that was given to you by this bank, or Cody does, he's going to just log right in. And it's going to look seamless from the victim's perspective. All right, so that's redirection in 10 easy steps. So here's a code example that it kind of shows sort of the same thing. We've got a redirect, and we're basically catching this on save value, and we're doing save page.setRedirect. And when we do this, when we set up the page reference with the on save value, which we're pulling from the Apex current page parameters, when this happens and we return, it's all going to take place, right? Right inside the Apex, the redirect is going to take place, and the vulnerability is going to be exploited. So the core Salesforce product uses these redirects all the time, right? And it's really important to know that the casing when you're typing these into your Apex backend controllers was very important. Because start URL with the way that it is up here, or save URL or cancel URL, those are very important. The casing is very important. So if you try and mess with one of those as a hacker and send you the link like I just showed, you're going to get this invalid page redirection, right? Because the platform itself has detected that that something has changed and you're not supposed to be going there. But it's great to note that ret URL and ret URL and ret URL, those are not equal, okay? And so if you set something to ret URL and then try and redirect a user to that, the platform is not going to detect that for you and protect your users, okay? Okay, so this is kind of what I was just talking about, breaking the Salesforce mitigations. If you're familiar with Apex, you may know that Apex is case insensitive. And if you're doing redirections anywhere in your code where destination is exposed to the user, like URL parameter that we showed, or a form field, you must put an additional layer of protection in your Apex controller. Okay? So here we can see we're pulling the we're pulling the ret URL out into some string called onsave, and then maybe we would use that later to redirect the user. So how do we mitigate open redirects? We've got hard coding. We can hard code the redirects. That's one way. We could only allow local redirects. We could have some sort of a whitelist or something, or make sure that it starts with a /. Okay? Or we could do, like I said, a whitelisting domain kind of approach. All right? There are ways to detect these vulnerabilities in your source code. We've got some free static code analyzers. We've got PMD. There's a link here. We've got the Force.com scanner portal. There's a link there for that as well. You can go check those out. So what did we learn? We talked about SOAKL injection, how to mitigate some of that. We talked about the locker service a little bit, and some Lightning components. We talked about open redirects and some secure coding standards. And of course, we started with cross-site scripting. So I hope you all took something away from this. I will be over at the security station for questions directly after this. And please go to some of these other talks. You're in this talk now. We got a couple more today and some more tomorrow as well from the security team here at Salesforce. So thank you all for coming. Have a great time at Dreamforce.